Swayam Prabha. Digital India. Educated India.
So welcome all, day 2 of the Gian course, day 3 of the Gian course, and this experiment that Sudarshan explained you is particularly about the aluminum. So you see aluminum is being used everywhere. You used aluminum utensils in your home, you used aluminum decoratives in your home, aluminum car bodies. But aluminum is also a bulb element. So what being my bulb element? You leave it in nature, it will oxidize. It will form Al2O3. Al2O3 formation is used in the industry for the protection of these aluminum coatings. So starting in 1857, first anodization was done, but 1935 it gained attention of the people and started being used in the industries to form a protective coating on the decorative element. But in 1995, there was an invention by Masuda who told you can do a porous oxide on the porous oxide formation on aluminum. After that happened, you can use this porous oxide to put colors in it. So what I will take you through is see the part synthesis of 1D nanostructure. So for this AO template that is being synthesized, fabricated in our lab, you can use that for a nanomaterial synthesis. You can use in your cooking utensils that has, and you can put a color or sealing. As Ambad sir told, you can use for a sealing of the laptops also. So how this happens is the major point of this. When you do anodization, it happens two types. It forms barrier coating or a porous coating, as Sudarshan explained you. But why barrier and why porous? Aluminum is being anodized by 1935, but why in 1995 people invented that you can form a porous oxide? So the reason behind is the electrolyte. When you use the electrolytes such as chromates and borates, you will get a barrier coating. But when you come to organic electrolyte like oxalic acid, citric acid, you will form a porous oxide. But what is the mechanism? So before going into the mechanism, this full setup, these are power supply, 30 volt, where you can supply a potential. And this is full is a two electrode setup, where anode is aluminum. There will be a small coupons of aluminum. So these are the small aluminum coupons, electropolished. And then this is the platinum electrode, where Sudarshan explained you there will be two reactions happening. Hydrogen evaluation will happen on the platinum. The other reaction that give you porous nature. The middle part of AO template on the first schematic you can see is the holes. That will be your porous AO template. Now, first step in any anodization process on any electrochemical polish, you will do electropolishing. You do electropolishing, you will clean the process. Now, when you do start the porous oxide formation, this will happen in full process of forming the porous oxide that we use in our lab is a two-step anodization process. But for the start, there will be we call the first anodization. So what happened in a first anodization process? This is a electropolished sample. So it will be a clean finish. Then you will do first anodization in an oxalic acid electrolyte, citric acid, or whatever you want. Even in the sulfuric acid you can do. And you will apply a certain potential of 45 volt. The formation of oxide happens due to two competing reactions over it. So when you have an aluminum, when you switch on the potential, instantly there will be a barrier layer formation over the aluminum template. When the barrier layer formation happens, after that what will happen? There will be a certain defects over the AO template, the template that is being formed, and that will result in a high current density at those effects, which will start the overgrowth over those areas. That will be a localized current density will be there. When you have a localized current density, through the equation you know that the higher current density, there will be higher oxide growth at that point. How this oxide growth is happening? When this oxide growth is happening over it, where does the aluminum is coming from? Because you have almost formed the barrier layer is there. That will result in the migration of ions from inside aluminum template. The Al3+ will go up, O2 will come inside. So at the same point, when your oxide is being formed, when the overgrowth is happening, there will be a resulting reaction on the aluminum itself, where another oxide will be coming up. This oxide will result in a U-shaped structure. It will start consuming the U-shaped structure. Okay. When this U-shaped structure starts coming, after a certain point of time, the steady state growth you will achieve. When you will achieve a steady state growth, then porous layer will form. The walls of these templates are formed of oxalates and other chromates that ions you are using. So there will be two competing reactions happening over it. One is the oxide overgrowth that is happening because of high current density, and another will be an interface at the metal and oxide already. So two interfaces, oxide and electrolyte, oxide and metal interface. These two result in your porous layer growth, this porous cylinders growth. So Sudarshan showed you the U-shaped structure that you are achieving. The second picture that you are seeing is a hexagonal shaped structure. These are hexagonal cylinders that comes up. And there will be an oxide formation, U-shaped oxide formation will be there. Now, while you are doing the anodization, there should be a stirring. Agitation should also be there. Now, agitation is there, you have for not just electrolyte, the proper potential also plays the role in achieving the porous oxide layers. So when you have you can do, Sudarshan explained you hard anodization, where you just plug a 250 volt or 180 volt aluminum, you will achieve a hard anodized structure, will be a barrier layer growth. Now, when I have done the first anodization, what happens actually is, there will be a non-uniform. There is a tubular structure, but it will be non-uniform. Why non-uniform? Because it's coming up from the defects. So you see the second schematic, where it's electropolishing, first anodization, second part is oxide etching. From the Pouvet diagram that Ambad sir and Lakshman sir explained you know that in highly acidic condition, the oxide will go. In highly basic condition, oxide will go. So highly acidic condition, the oxide left. Then you have then after you did the oxide etching, there will be a pattern over the surface. Now, after that pattern, you can actually use to do the second anodization. When you will do the second anodization, then there will be a proper oxide growth. That proper oxide growth you can achieve, then you can widen the pores in this. So why I use for my nanostructure, or in our lab, why I use for nanostructure synthesis, you can tune the dimension of this AO template. When you start the tuning of the AO template, then you can achieve whatever dimension you want. So this can be used for synthesis of nanomaterials or nanowires. 1D nanowires, in our lab, nanoflowers has also been synthesized. Now, after you have achieved that, after you have done the AO template anodization, for second anodization has been done, what you can do, you can deposit material inside this. So this is not a proper deposition of the material, but this is a copper deposited inside it. Now, this is a copper nanostructures, 1D copper nanostructure. Or you can use it to fill the colors. The sealing that Ambad sir explained today. This color, using a dye you can do. And you see, probably you will say, this is the, I should have shown you earlier, this is the second anodized coupon. So by naked eye, you cannot see the difference between two. But there is a difference. What difference? If you observe properly in the light, you will see one other is highly shiny, another is not that much shiny. So while you are doing anodization from this also, you can see that whether the reflection is proper or not. Using this, after you have anodized, so we have here anodized aluminum wire. You can use that as a decorative element. You can dye it. And probably I should show you an industrial application. So the industrial application you can see in this pressure cooker. So this is actually anodized aluminum, where you put the dye in the color, and then your aluminum can be used in your homes for a protective layer. If you use it properly, it will go over the years. You can do anodization both ways, potentiostatic or galvanostatic. By potentiostatic, we mean at constant potential. When you are applying a constant potential, there will be a certain current inside it. But during potentiostatic method, the current will be changing, but that will be not subsequent. But you can also use a galvanostatic method, where you can use using the area of the working the exposed area that you want to anodize, with the current density you can apply and do the anodization. But there the potential will remain changing and the current will be constant. So the current is changing, but you're not, at this point you're not applying the current. It's fixed actually.